Woohoo, look at you. Go. Love it. All right. So in 3.1, we're talking about simple stuff like what a statement is, right? So a statement is basically something that has to be either true or either false. It can't be an opinion. It can't be something that true one day, but false another day. Well, I shouldn't even say that. I should say at the moment in time if it's true or false, okay? It shouldn't have a gray area. It's got to be either black or white, all right? Negation is basically their opposite of that particular statement, right? So usually we use not, or it is not true that, or it does not. And we usually use P and Q to represent a statement. I would tell you to use a letter, and it's usually lowercase letters. And I would use, if you guys got a bunch of statements, I would use a letter that makes sense for that statement. It doesn't have to be P and Q's all the time, or R or S or T. Those are typically their common letters that they use, right? So if you guys look at this, you will see that this little squiggly here in front of P means this is the negation of P, or not P, we would call it, okay? And the quantified statements would be statements that contain the words all, some, or no, or none, okay? So it's one of these three, right? Those are statements. So a statement that you could write is right? It's not an opinion. It's either true or false. That's a statement. Make sense? I don't like her dress. That's not a statement, is it? This would be an opinion. Okay, so it's not a statement. All right. So you guys got to understand the difference of those two. Any questions on that? Pretty easy. Okay, so so those are statements. And then, like I said, if it's not, right, if I was to do like the negation of my statement there, correct. Chan is not Chinese. Well, it's an opinion, so it won't be a statement to negate. So that's why I'm not even negating it, because it's an opinion, okay? You can say it is not true that Chan is Chinese, right? And if this statement, let's say, now with this statement, you might want to just use lowercase c. Then these two would be squiggly C or not C. Right? You don't have to use P necessarily. Are we okay there? Yeah, so it can be any letter you want. All right. No, opinion, we don't do anything. Yep. If it's opinion, it's opinion. It doesn't, we don't negate, we don't do anything with it, because it's an opinion, is no longer a statement. So we don't even negate it. So quantified statements, as you guys can see here, all A are B. So I wrote down below it, all poets are writers, right? So all A are B. So you could have wrote this as all P are W if you guys wanted to. So these will be the equivalent of it, right? So saying all A are B is the same as saying there are no A, there are not B. So writing in a sentence, there are no poets that are not writers. Some A are B. Some poets are writers. Equivalent to that, there exists at least one A that is B. There exists at least one poet that is a writer. No A are B. So no poets are writers. Well, it's the same as saying all A are not B. All poets are not writers. Some A are not B. Not all A are B, which is the same as saying some poets are not writers. You can say not all poets are writers. So these would be your equivalents of your quantified statements. So again, quantified means that you have all or some or no or none. But none poets are writers doesn't make sense. I know, crazy, right? So you can write down all Chans are Chinese. Then you would say equivalent to that would be there are no Chans that are not Chinese, which that is false because there are plenty of Chans that are not Chinese. Like my sister-in-law is a Chan. She's not Chinese.
What?
Because it's my sister-in-law. She married my brother, who is not Chinese, but her last name is Chan. So she's a white Chan. And she's not Chinese. Make sense? So we were to negate. Now, it seems like a lie here, but this is actually flip-flopped, right? Because what you're going to see is that, see the some are not B? You're going to see that again. Okay? You know what I'm saying? Because this goes both ways. So the opposite of, or I should say the negation of all A's are B is some A are not B. And the negation of some A are not B is that all A are B. Huh? It is. Yes. Yes, it is. Some A are B would mean that no A are B. So if you guys notice that it goes from all to some to no, and then it goes backwards as well. So some would go to all, no would go to some. Okay? So all right. Okay. So then we get into conjunction and disjunction. Conjunction are and statements. And if you guys notice, this almost looks like an A. So that will remind you that the and statement is the one that looks like an A, and the or statement will be the flip of it. And can also be replaced by but, yet, nevertheless. And as you're doing more and more problems, you're going to see these words popping up more and more. But with or is only the or, and that's it. Okay, doke? Any questions in that of that? And the two, so in other words, now there's going to be two statements. Chan is Chinese. And Chan is a professor. Right? This is true and this is true, right? So it could be, let's say, before I even write the true or true, I should say, so I could call this C and this P, and this would be C and P. Well, you want to use T and T because it's a true and true. So we'll get to that with the truth tables, right? I guess you could write down Chan is Chinese, but he is a professor. Or Chan is Chinese, nevertheless, Chan is a professor. So you guys are going to be looking at literally 4 different types of statements, right? You got the conjunction, which is the and, the disjunction, which is the or. You're going to have conditional, which is the if-then statement, which is represented by the arrow. And these are all different ways of saying this. So sometimes you guys got, and here's the fact of the matter, is that until you see all of these used, and you make the mistake and you go, oh, this is an if then. That's the only time you're going to really learn it. If you're just going to try to study it this way, none of it is going to sink in whatsoever. I promise you. Okay. You're going to actually have to go, I'm guessing it is this. And then this says, nope, you're wrong. And you're like, okay. And then you see the answer and you're like, oh, it's an if then statement. Now I see it, because you want to see this if, and you're not going to be sure if it's a if and only if, which is a biconditional, which is the 4th statement that you're going to be looking at. Only if, you might definitely think it's a if and only if, right? So you have to kind of, like I said, see the problems, do the problems, make the mistake, and bounce back. All right. And then let's talk about the biconditional. Okay. If and only if. So I would say this. The reason why it's biconditional is because really what you have is a P then Q and Q then P. That's why it's biconditional, because it's going in both directions. Okay, that's why the double arrow here is because both directions have to work, right? So it's not just P to Q, but it's also Q to P. So if you look at these right here, right, P is necessary and sufficient for Q. Q is necessary and sufficient for P. It's going both ways. So notice that it's using necessary and sufficient. And up here, there is only necessary or sufficient, not both. Right? And notice that basically this is why I just wrote down here. If P then Q and if Q then P. These would be considered biconditional because it is going in both directions. Any questions on that? So all dominance is, it really isn't a big deal because, well, dominance is going to come in when we have like compound statements. For example, like something like that. they're going to ask you what kind of statement this is. And what you would do is you're looking at these operators, right? You're looking at these operators and you're asking yourself, which one is the most dominant? Which in this case, the biconditional is the most dominant. So this would be a biconditional statement. If this was just this, then it's going to be conditional is the next thing. So this would be considered a conditional statement. Okay. Now the truth tables. I think the truth table is probably the most important part here. Because a lot of times you're going to have to like negate a sentence. That's pretty easy, right? The quantify statements are going to be a little bit tougher to negate because you're going to have to remember, is it, you know, which one, what am I supposed to use? I see the sum. Am I supposed to use all or am I supposed to go no? Okay. All right. So obviously, if I'm given the P is true, then negate it, it'll be false. Make sense? If it's false, if I negate it, it'll be true. It's kind of like if I negate a positive, it'll be a negative. If I negate a negative, it'd be a positive. Now, I think the bigger question is, how do I create a truth table? That's, I think, the bigger issue here. Okay. So I would tell you that what I figured out is that the number of letters if you take 2 and raise it to that power. So here on the truth table for negation, I only have one letter, P. So 2 to the first power is 2. So notice that I have 2 rows here. Here I have P and Q. So number of letters is 2. So 2 raised to the second power is 4. So that's why I would have 1, 2, 3, 4 rows. Okay. So I guess I would put this as number of rows equal. Okay. And I want you guys to notice something. What I would do is half of these will be true and the other half will be false. And then I alternate. But really, it keeps on going to half. So half of 4 is 2, right? And then half of 2 is 1. So for example, here, I would do a mock truth table here. Let's say I use P, Q, and R. So how many rows should I have? Huh? 9? What's 2 to the third? 8. That's 3, 4, 5, 6, 7, and 8, right? Actually, I think 8 is going to be down here. No, that's right. So again, I'll go half. So on the very first letter, I'll go half of it is true. So half of 8 is 4. There's 4 trues, 4 falses. Anybody see that? What's half of 4? 2. So 2 trues, 2 falses. 2 true, 2 falses. And half of 2 is 1. So true, false, true, false, true, false, true, false. Does that make sense? So I start with 8, then 4, then 2, then 1. If there's 12 letters, yeah. It'd be 2 to the 12, which is you're gonna run out of paper. Most of your stuff is only gonna be 3 at most. I don't even see 4 were being used because that'll be already 16. So you gotta go 8 and 8 trues, 8 falses, 4 true, 4 false, 4 true, 4 false, and then 2 true, 2 false, 2 true, 2 false, 2 true, 2 false, 2 true, 2 false, and then true, false, true, false, true, false, true. The number of letters. Yep. So if there's a P, Q, and R in there in the statement, then that's exactly what you would do. You say, okay, yes. It's 2 to the number of letters. So how many letters are in here? Right, P, Q, R. So that means it will be 2 to the 3rd, which is equal to 8. Yeah. You show me. No. I say be consistent with exactly this. Always start with trues, right? So if you're always if you want to do it as always starting with false, then this true table will be exactly the opposite, the upside down version, right? So I would say always start with true. So because I have 8 rows, I know it's gonna be 4 and 4, and then 2 and 2. But those 2 and 2, I'm staying with, since I start with true from the get-go, I'm gonna go true, falses, trues, falses, true, falses, right? And then true, false, true, false, true, false, true, false. Don't keep on switching back and forth and being inconsistent, because that's when you get into trouble and mistakes being made.
There's always 2 to the number of letters?
Yep.
Always 2. Okay.
Yep. Because how many choices do you have between true and false? There's 2, right? So essentially this is binary as well. Just like computer language is binary, yes? So binary is 0s and 1s, so it's just trues and falses, yeses and nos, and that's it. Right? So since we're dealing with trues and false, that's why it's a base of 2 and then raised to whatever power. Cool? And this is apparently going to be part of the video of me cracking open the monster. If I could just have the video go. Yes. Make sure you click the subscribe button. Hit the notification. All right, so with conjunction. So conjunction is an and statement. Okay. So notice how the table was built, right? There's 2 letters, so it's 2 to the 2nd power, so there's only 4 rows. Half of that is 2, so it's 2 trues, 2 falses. Half of that is 1, true, false, true, false. When I do an and, so here is how you will remember the and. Ready? So I know that all of you boys and girls who are younger, when parents ask you a question of what you did last night, you guys tell the truth, just not the whole truth. Am I right? Ashley, like, no. Right? Well, it's out, it's out of love. You just don't want them to, feel some type of way. That's all. You're trying to take care of them. Right? So if I was to say to you, I am going to post these notes and post the videos, right? If I do only one or the other, am I lying to you? I told you I am going to do this and this, right? I'm going to post the notes and I'm going to post the video. If I only do one, but not the other, did I lie to you? With the and, I am lying to you. The only time that I'm telling you the truth is if I do both. Does that make sense? Because I told you I'm doing both things. Right? So that's why if you notice, only time is that if I do post the notes and I post the video is the only time I'm telling you the truth. If I do one thing but not the other, it's false, meaning I lied to you. If I don't do the first thing, but I do post the video, I'm still lying to you. And if I don't do either one, I'm definitely lying to you. Make sense? So now there's a different way that you can talk to your parents when they say, where are you guys going tonight? Don't use the word and, because then you might be lying. Because there's disjunction. Disjunction is or. All right, notice the truth table is the same way, right? There's two letters. 2 to the second power is 4. So there's 4 rows. Half of that is 2. Half of that is 1. Now, or if I said, I'm going to post the notes or I'm going to post the video. If I do one or the other, I still didn't lie to you. I used the word or. Make sense? So if I happen to do both, I'm still telling you the truth. If I post the notes but not the videos, I'm still telling you the truth. If I don't post the notes but post the video, I'm still telling you the truth. I still didn't lie to you. The only time I will be lying to you is if I don't do either thing. Then I'm definitely lying to you. Does that make sense? Yes.
So basically, the B is basically or and the other symbol.
The shell of A is and. Right? Because this looks like the shell of A, right? Make sense? And yeah, and then so since that's the and, this must be the or. Any questions so far? I'm gonna focus on conditional first. So let's say I say to you, if you wash my car, I'll give you $50. Do you think that's a good deal? It's a very good deal. $50 to wash a car?
Oh, this also?
What if you detail it?
Yeah.
You know?
Okay, if you wash the outside of my car, I pay you $50. Is that a good deal? Okay, so it's a good deal. $50 is more than you need. I can go through Sam's Club for like $8. If I go to a car wash place, I can get like, you know, the bottom scrub and wax and a back rub. It'll be like less than $50 as well. I was gonna say other things, but wasn't gonna go there. My back rub, we'll call it that. All right. So that's a good deal. But if you wash my car, the outside of my car, and I don't pay you $50, is that a good deal? No, bad deal, right? That's why it's false. If you don't wash the outside of my car and I pay you $50, is that still a good deal? Yes. Okay. Well, if you don't wash my car, the outside of my car, and I don't pay you $50, is that still a fair deal? Yes. Okay. And it's funny because when I taught this in high school, it was $5 and it was still like a good deal then. Now it's like $50 with a tip. What the heck happened? Now, biconditional again is both directions. Right? So if you look up here, if I look at just this piece right here, or should I put it this way? So if I look at this, true, biconditional true, that means, oh, I shouldn't use that because then that means that I have to have this and I have to have the other way as well. Well, this is true and this is true. So what's true and true? True and true. So I have to go in this direction and I have to go in this direction. If I look at the conditional, it's both true. And if I and that or conjunction that still come out to be true. Now this one here, I have to go true to false, meaning if you wash out my car, I don't pay you $50. That's no good, right? And if I say this, false to true, meaning if you don't wash my car, I still give you $50. You're like, oh, that's a good deal. Well, what is true and false? Huh? And if I do one but not the other, it's false. False then true. If you don't wash the outside of my car, I pay you $50. Good deal, right? And then true to false, meaning if you wash the outside of my car, but I don't pay you $50, that's a bad deal, right? Well, what's false and true? And then false and false. So if you don't wash my car, I don't pay you $50. You say still a fair deal. And the other way is saying the same thing, right? If you don't wash the outside of my car, I don't pay you $50. It's still a good fair deal. So that would be a true and true. So that would give me true. Okay. So I'm just giving you guys different ways of remembering these, how these tables result. Equivalent statements. So if a compound statement is true, then an equivalent statement will also be true. And if it's false, then equivalent will also be false, which is not like, that's like the English language right there, right? Okay. So in conditional, there are different ways of writing it. Okay. So the way we wrote the conditional was if P, then Q. The converse, so you guys are going to need to know what converse, inverse, and contrapositive means. All right. So to me, the easiest way is to remember switch, negate, switch, and negate. Converse are sneakers. Yes. You would switch your sneakers. So that'd be switching. So it would be if Q, then P. Inverse would be negate. So you would take the original statement and negate both of them. Not P, then not Q. Contrapositive means to switch and negate. So you got to switch the symbols, right? The P and the Q, you got to switch them and negate them both. So that's why it's not Q, then not P. So let's go ahead and prove the fact that the conditional, the original, is equivalent to the contrapositive, while the converse is equivalent to the inverse. So let's take a look. So let's go ahead and make a table. because I'm sure just hearing words are confusing in math already, right? So we got P, we got Q. So true, true, false, false, true, false, true, false. Okay. So let's look at P, then Q. Let's see if you guys remember this. True. Go ahead.
Is it ever gonna be like false, false, true, true?
No, if you're gonna do that, be consistent. If you're gonna go false, false, true, true, then go with false, true, false, true. If you do that, then make sure you stay consistent. That's all. Okay. All right. So what is this right here? True, then true is going to give me what? True. So if you wash my car, I don't pay you $50, right? That'd be false. Next. True. If you don't wash my car, I still give you $50. But it's still true, right? Because again, if you don't wash outside my car, I don't pay you $50, right? So that means it's still a fair deal, but my car is still dirty and you didn't get the $50. So it's still a fair deal. Okay, well, let's do the same thing. But let's change. I don't want the style. But let's do switch and negate. So I'm going to switch the Q and I'm switching the P. And I want to negate both of them, right? Now, this is a lot harder to do. So I'm going to show you a little different trick. I'm not going to try to do this all in my head. So I'm going to move this down. What I'm going to do first is this, is I'm going to make more rows. Wow, that looks so straight. By that, I mean it doesn't at all. So what I'm going to do is I'm going to negate the Q first and then negate the P. Then I would do this. Does that make sense? Okay. So let's go ahead and negate the Q. If I negate the Q, it's going to be what? I'm negating the Q. True is going to turn into what? False. False is going to turn into true. True is going to turn into false, and false is going to turn into true. Okay. Now let's negate the P. First one is going to be false. Then does that make sense? So in other words, when I'm negating a Q, I got to make sure that I'm looking at the Q to negate. When I'm negating the P, I got to make sure I'm looking at the P to negate. Does that make sense? All right, cool. Now what I'm going to do is I'm going to now only look at, I don't want to look at the first two anymore. I'm going to look at the last two. Right? Does that make sense? So, okay. So if I do this, that means I'm doing this, right? False, then false is what? If you don't wash my car, I don't pay you $50. It's true. False, if you wash my car, I don't pay you $50. And this one. Right? So now look at the end result, guys. Is the same thing, isn't it? So that's why we know that these two is equivalent. So equivalent symbol is like this. It's like the 3 symbol in Chinese, or the equal sign with a line underneath it. Okay, so that's how I know that it's equivalent. So the equivalent statement that you saw up here is exactly what that is trying to say to you. Fair enough? Okay, so that's what equivalent means. And that's how I know that the original and the contrapositive are equivalent. Okay, I know a bunch of words is not going to solidify it for you, but here's where you can see it being solidified. Is that fair? Any other questions? Ask your questions. Which part? Tell me which part. From the beginning? You get the rows in the truth table, she said? Between what? Well, go ahead and ask your question. Okay, this one right here, why this is true, but this is false. So remember, conditional, I gave you the car wash idea, right? So this is saying, if you do not wash my car, then I still pay you $50. Is that a good deal? Pretty darn good, right? You don't have to even lift a finger, you got $50. You're like, yeah. Can I not wash your car more often, please? Right? Where this one says what? You wash my car, and I said, have a good day. Yeah, and you don't get the $50. Is that a good deal? Heck no. You're gonna say F me, right? Right? But all the other ones, if you don't wash my car and I don't give you $50, it's still a fair deal, right? You're not gonna tell me F off, right? Same thing here. If you wash my car and I gave you $50, you're still not gonna tell me to F off, right? Ashley might say it'd be nice if you gave me a tip, dude. Correct. Correct. Well, this is to show that these two are equivalent. Okay, so I made a table here for one, which in this case was the conditional, right? P then Q. Huh? Mm-hmm. So let's say, for example, maybe you were given a statement. Let's do it this way, because I'm definitely not smart. I'm not really even that smart in math. But let's say that is a statement, right? So the contrapositive of that, right? So this is a statement. So if I want the contrapositive, well, contrapositive is to switch and negate. So I have to take these two. So if you look at this statement right here, let me do it this way. You see my two statements right here, right? Because you see the if and the then. So I know that this is going to be this, right? So now I got to take those two statements, switch them, and negate them. well, and negate them. So this would be if Chan is not smart in math, then he is not. He is not good at English. No, then he is not Chinese.
Oh, so I have this not smart and not right, or
Yep. So you notice I negated this one here, and I negated this one here. All right. So now you see the purple statement here, but negated, and you see the blue statement here, but negated. Okay.
you put me.
Right.
Mhm.
Okay. With contrapositive, yes, you have to switch and you have to negate. You got to do both. Okay, so I'll put that in blue. So if you say if Chan is not Chinese, then he is not smart in math, right? So this I only negated, right?
Right.
Wouldn't that be an inverse? Because if you look up here on this thing here, which one does it say is just to negate? Right? If I was just to switch, right? If I had said Chan is, I'm sorry, if I was just to switch, then it would say Chan, if Chan is smart in math, then he is Chinese, right? They're both still on a positive tone, but the two statements switched. Okay. Now, are you going to have to do both things? Are you going to have to be able to do it with a statement and with symbols? Yes, you got to do it for both. This is called logic. This is logic. Trust me, there's logic behind when kids lie to their parents, right? There's some kind of logic behind in their heads, right? I just stayed over at someone's house. You just didn't say that there was a party going on, there was a bunch of drinking going, and you know, a bunch of illegal things happening, but you stayed over at the house though. So you told the truth, just not the whole truth, right? That's where you go, I'm gonna go to the movies or I'm gonna stay over someone's house. Because now if you don't do both, you're not lying. But if you say you're going to the movies and you're going to stay over someone's house, if you didn't do both things, you lied. Make sense? You guys gotta go home with, or you want to really emphasize that so that when they bring it back up, you're like, I said or. I didn't lie to you. So yeah, you're gonna have to do it with statements. So does that clear things up, you said?
Yeah.
Okay. So where else are we lost? Yeah, PQU2. Yeah, so like I said, sometimes it's just having to do the work. This is the most, this part here is the part that is a punch in the mouth. And I will have this part for sure on your cheat sheet. Because again, up here, what I said to you was, right, is this, is that the conditional and contrapositive are equivalent. They are essentially the same thing. They're essentially equal to each other, but they're just equivalent to each other. The converse and inverse are equivalent to each other. So in other words, down here, when I wrote these two statements right here, guys, these two are equivalent statements of each other. Okay. And then the converse and inverse are equivalent to each other. And it's not saying, now notice that I did not say anything about the negation of a conditional statement here, right? Right? There's a bunch of negations in there, but I'm not negating the conditional statement. So the negation of the conditional statement is this: P and not Q. You're like, what? How did a conditional statement, if then, change to an and statement? Okay. So yes, this will be in your cheat sheet. Okay. Now, De Morgan's law has already shown up once or twice, well, once in your life already. Do you guys remember that? It was with the union and an intersect, except instead of U, it's a V. Right? Instead of upside down U is now an A, right? Or a shell of an A, I should say. It's all right. Oops. The problems with this. All right, so testing validity of an argument. Ooh, this is where the work comes into play. Use a letter to represent each statement. Express the premise and a conclusion symbolically, which is what we did before. Actually, we went symbolically to the expressions. Write the symbolic conditional statement of the form premise 1 and premise 2 and premise 3 and so on and so forth. Then the conditions. So I'm going to go ahead and show you guys some of these. Construct a truth table. And then if the final column is all true, so the final column has to be all true. Okay. So for example, right? So if Chan is Chinese, then he's smart in math. So let's say this is C, then M, actually, right? And that is premise number 1. Premise number 2, actually, let me write it this way here. Let me do it this way, guys, sorry. So that you guys can actually see what kind of problems you're actually looking at. Okay. Let's say the second premise says so how would I write that in symbol? Chan is not smart in math. Squiggly. See? Squiggly M. Because remember, the C part is that he is Chinese, right? M is showing that he's smart in math, right? Because if I use P and Q, it would be, I would think that would be more confusing than using C and M. Make sense?
I would go by C with a channel.
Yep, understood. All right, so let's say that the conclusion that they have is not C. So in other words, therefore, Chan is not Chinese.
So the therefore will do that.
Yep. No, yes. Well, conclusion. Yes. Therefore. Which when you come to conclusion, but therefore. Everybody okay so far? So the problems that you would see would look like this. And yes, there will be a line here after however many premises that they give you. And then the very last thing will have a 3 dots and it will see your conclusion. If it's in words, it will look something like this. Okay. So you might have to go from words to symbols, then go to the truth table. Okay. So when I go to the truth table, here's what I want. All right. I want you guys to watch closely here. So here, if I'm correct, premise 1 is this. Premise 2 is this. Conclusion is this. So it's premise 1 and premise 2, and then the conclusion. Everybody see that? So that is what I'm actually doing. So I have to show the truth table for this. So in that case, let me go ahead and move this here down so that we have some space to do this truth table. Okay. So that is a truth table I got to come up with. How many letters do I have? 2. So how many columns do I need? I'm sorry, how many rows do I need? I need 4. Look how nice my lines look. There's my 4. Half of 4 is 2, so true, true, false, false, true, false, true, false. Now, here's the scary part. This is going to be a lot of work to get an answer that is either all true or not all true. Okay, so here is kind of a strategy that you guys might want to use. So I usually look at this, and essentially I want to try to have all of these together. Okay, so for example, I see this, so I'm going to go ahead and write this down right now. C to M. Oops. Okay. So what is true then true going to give me? True then false? False then true? False then false? It's okay. I sometimes have to run through those sentences myself. Okay. Then I'm going to go ahead. I see this right here. Negate M. Right? So I'm going to go ahead and negate M. So if I negate M, I have to negate this one here. So what is it going to be? False, true, false, true. Okay. Okay, why don't I go ahead and take care of this whole thing right here, right? So I want C to M. And not M. So now I'm going to be looking at what two rows? I'm going to look at this row here, right? And this row here. And it's going to be and. So what is my result going to be? Is this going to be true? True and false? Is it? True and false? So again, I'm going to have true and false. It's false. How about false and true? Again, this is and. So that means I have to do both in order for me to not be lying. This is true and false. And true and true. That would be true. Okay, so far? Well, the and is if I do this and this, right? So if you told your mom that you were going to go to the movies and stay over someone's house, if you only do one or the other, you're lying. Right? So you're at someone's house and she calls and she goes, so how was the movie? You're like, I didn't go. She can say, why did you lie to me? You told me you were going to do both and you didn't. Right? But if you did do the movie and you would say, yeah, the movie is great, and now I'm at so-and-so's house, right? Then that'd be okay. All right. So it's okay for you guys to kind of write this on the side, right? If you guys make the table big enough, and then just make sure that you write these bigger, right? Okay. So the next thing, now I have this part right here done, right? So now I gotta get this. So I need to do a not C. Okay, what's not C? What do I get when I negate C? False, false, true, true. Then now I can do the whole thing. C to M and not M, then not C. Woo! That's a multiple. So essentially I'm just doing this, yes? Is that right? What's false then false? True. False then false? False then true. False then true. Because if you don't wash my car, I give you $50. What? The signs are confusing what? Yes. What mean to remember what? Well, in terms of truth table wise, you know, like I was saying to you with the conjunction, right? With this one right here, with the conjunction, it's about, you know, the conjunction and disjunction is about lying, right? So So that's how I usually remember it, is that if you tell me you're doing both things, this and this, you have to do both in order for you to be telling me the truth, right? If you only do one but not the other, you're telling me a lie. But with the or, if you do one or the other, then you're telling me the truth. The only time that you're going to be lying to me if you don't do the either or, right? If you're telling me that you're going to go to the movies and you're staying at someone's house, and in actuality you were at, Comic-Con, you're totally lying to me because you didn't do either one, right? And the if then would be the car wash. But the biconditional, you have to look at both directions. So you can still use a car wash idea, but now you got to do it twice, right? So with this, you just have to go, okay, so this, my goal is to try to figure out if the last column, the final column, is going to be true, all trues or not. So I have to do the first statement and the second statement, then the conclusion. So I have to play with the table so that I have all of these together, right? So some people will try to do this all in their head, which I do not recommend at all. I would tell you, I would have, myself, I would prefer to have more columns to lay things out easier for me, right? So if you notice, I go, okay, let me do this part here because then I can see this. Let me do this part here so I can see that. So now I can just say, okay, I'm just doing an and between these two things here, right? Now I can go, okay, so lying, okay, and so true and false. Well, I did one but not the other, so I'm lying. I didn't do the first, but I did the other. I'm still lying. I did the first but not the second. I'm still lying. I did both. Yes, I'm telling you the truth, right? And then when I come here, so there's a nice thing about having the iPad is that you have this, and then you can kind of like zoom in and saying, okay, I'm only dealing with this. And that's why I put the arrows here to show you guys that, so that I can go, okay, false, then false. Got it. So on your notebook, you might just want to have like another sheet of paper and kind of covering up, or having strips of paper and covering up the columns that you don't need, right? Kind of like when you did the not C, it'd be awesome to just say, okay, I'm looking at just the C, right? But being able to covering up the rest of it. So you go, okay, C is true, true, false, false. So not would be false, false, true, true, right? So it's a lot has to do with not looking at the whole table as one, but looking at bits and pieces as you're going of what you need, okay? And putting the columns next to each other so that you know what you need to look for only, or look at only, okay? Now, if there was a single false in here, then this statement would be invalid. The conclusion would be invalid. Does that make sense? I know. I agree, Diego. It is very frustrating. It's like literally speaking a different language. Are we okay? So they're going to tell you that there are valid arguments and invalid arguments and what those names are. So I will leave this as on the cheat sheet as well. So if you notice, the inverse right here is exactly what we just did. I know it's hard to see because we had what? We had C to M, and then we had not M, I'm sorry, not C, sorry. And then the conclusion was not M, right? So we had this inverse right here, but this inverse right here was an invalid fallacy or a misuse. Okay, so sometimes you have to compare closely to see it. You might have to actually rip off that cheat sheet and going, which one of these is it? Actually, is that what we had? No, we had the other way, sorry. So that's not the case. So we had this, let me write it out. We had C to M, we had not M, then not C. That's what we had, right? Yeah, not M, then, okay. So which one of these do we have? Anybody? Which one of these do we have? Was it a converse? Where the not M is there, right? So it wasn't inverse, right? It wasn't this. Which one was it? Huh?
Is it contrapositive?
Yeah. Does that make sense? And let's talk about Euler diagram and its arguments. So the Euler diagram is saying, okay, so here are the steps, and this will also be on the cheat sheet. Make an Euler diagram for the first premise. Make the Euler diagram for the second premise on top of the first premise. The argument is valid if and only if every possible diagram illustrates the conclusion of the argument. If there is even one possible diagram that contradicts the conclusion, this indicates that the conclusion is not true in every case, so the argument would be invalid. So the closest thing I can get to this in my head in terms of what you've done in math in the past is a vertical line test. So on the vertical line test, you're trying to put that vertical line somewhere on the graph that it would intersect more than once. Does that make sense? You're constantly trying to prove that it's not a function. Same thing with this Euler diagram. You're trying to prove that it is invalid. That's your goal. If you can't prove that's invalid, then it must be valid. Okay. What does the diagram mean? The diagram is almost like a Venn diagram. So for example, let's say that it says, let me pick an example here. Where was the example I just picked? Oh, there it is. Okay, so it says all people are mortal. So there's people. All people are donuts. No, all people are mortal. That means every single person is inside the Venn diagram of mortals. Does that make sense? because that's what this is actually saying, that all people are mortals. Now, if I had this right here, it would say that some people are mortal. Make sense? And if I put it here, it would say nobody's mortal. So all people are mortal. And the second premise says some mortals are students. So where would I draw this circle? Like that, right? And these would be students. So what is the conclusion? So remember this line here, guys, remember the 3 dots? This would be my 3 dots right here, right? Because it says therefore, some people are students. So is this a valid statement? It is. Is some people, is this statement true? Some people are students?
Oh, no.
Correct.
Yeah.
Right? Because this has nothing to do with this part. It has this. Yep, because in order for some people to be students, this circle would have to intersect with the people, which it doesn't. Because this statement right here only says that some mortals are students. So this would be invalid. Does that make sense? Okay, so that's what the Euler diagram is about. Questions? None? Well, see, it actually doesn't like Venn diagrams. No, this one's fine. Oh, it's when you say the cardinal number is in a certain area. That's when you're like, ah! Okay, so let's do this. So if I do a donut, this would say that all A are B, right? Mm-hmm. But it's all of them. How about this? There's no A that are B. How about this one? Some A are B. And that is talking about, though, guys, just so you guys know, that is talking about this piece right in here, right? But what if I have the same thing, but I'm talking about this piece here?
Sum of A, most of A, sum of A is sum of B.
Some of A are not B, right?
If they talk about A.
Yeah, because I'm talking about where this location is. Right, right. So these might be some diagrams that might help you with your Euler. That's fair. Huh? That's the whole chapter 3 notes. Now I can answer questions from the lab work. What would you like to know?
Number number 4. And then number 1, I got it wrong at first, so I did it again, but it's A because of the sign.
Number what?
The one
Number 1 is A
it's only A because of the sign, right?
because it is a statement. And it happens to be a false statement, but it's a statement. It's not an opinion, right? 3 + 4 = 6 isn't an opinion. It's false, right? So that's why it's a statement. So number 3, you said? Okay. So let's look at number 3 on the lab work. So number 3 on the lab work says, they want you to negate this. Some pianists are not human. Okay. How do I negate that? So we can go up to the cheat sheet. Let's go up to the cheat sheet. Where's my cheat sheet? Oh, here it is. So it says some pianists are not human. Which one of these does it look like? Look like this right here, right? So therefore the negation is all pianists are human. Let's go back. Oh, went too far. So the negation would be all pianists are human. What choice is that?
Right? I mean,
That's how we just show our work, just write it.
Which is kind of sad because you guys can really look at the answer and just write it, and that's not really work. But here's the thing. Are you going to get it right on the test? Now, if you do the due diligence of going back to the chart and seeing it like we just did, there's no work to be shown. I agree with you. But at least you are knowing that I have a chart I can look at to help me with this. Because just doing that and then looking at the chart for the very first time on your exam, there's going to be 2 very different things. Number 4, given that P and Q each represents a simple statement, write the indicated compound statement and its symbolic form. So it gives that P is the outside is humid. I'm just gonna write down outside is humid. Because it says outside humidity is high. I'm just gonna say outside is humid. Okay. Q, shorthand. The basement dehumidifier is running. I'm just gonna say humidifier is running. Okay. And R, oh no, hopefully I don't have to do a truth table here. It says the basement is getting moldy. Basement getting moldy. Okay. So let's see. So the sentence says the outside humidity is high and the basement dehumidifier is running, comma, or the basement is getting moldy. Okay. So let me ask you this. How do I write this? The outside humidity is high. P. And what? No, and how do I write and? Basement dehumidifier is running. Or the basement is getting moldy. R. So I have P and Q, comma, or R. Is that right?
Yeah, but
Look at that comma. Ooh, that comma is awful. There's my comma.
no, but this is parentheses or no? B?
That comma plays a big role.
Well, there is no comma here.
Yes, there is. There's a comma right there. Am I right though? There's a comma right here. So if I write this statement, there's a comma really right there, right? Right after the Q. Okay. What is this comma helping me with? It helps me separate from the ending. Is what? As in dog? Yes, ma'am. That's why I'm showing you the comma. Makes sense though? It kind of like separates the two. What else we got? Say it again. So if you look at here, it says the number of children shop at shopping mall X who requested video games from Santa. Year 1, there was 19 of them. Year 2, there was 42. Year 3, there was 55. Year 4, there was 62. Year 5, there was 81. If there was a decrease in number of children at this mall requesting video games from year 1 to year 2, then more than 85 children at this mall requested computer games in 5 years. Wow. All right. Let me read the original thing first. In a small town shopping mall, market researchers recorded the number of children who requested video games while visiting Santa. The bar graph below shows the result of 5 consecutive years. Use this information given by determine the truth value. Okay, so number 10. So the statement says, if there's a decrease in number of children at this mall requesting video from year 1 to year 2. So if there's a decrease from year 1 to year 2, then more than 85 children at this mall requested video games in year 5. Then so what kind of statement do I have here? Huh? But what I'm saying, what kind of statement do I have? Do I have a conjunction, a disjunction, a conditional, or a biconditional? Is it an and statement? Is it an or statement? Is that if then statement, or is that if and only if statement? If then. Right? Because I have if this, then this. Right? So I have an if then. So I have this statement right here. Okay, what's before the arrow? Is there a decrease from year 1 to year 2?
No.
Well, you guys got to look at the graph. The graph looks like this, right? So there's not, so is that true or false? So I got false. Then more than 85 children requested in year 5. Is that true or false? So do I have a true or a false? If it's true, if it's false, then false, what do I have?
True.
Is it A? Now you guys look at number 6, look at where the comma is, or should be. Look at where the parentheses is for number 6. Look at number 6, see where the parentheses is. And now think about where the comma should be. So if you look at number 6, you see the comma, so the comma should come after the R. Right, before the parentheses, right? I mean, sorry, before the not P. So as you're reading these, you're going, okay, so not R, so after not R. So R says, we will visit Aunt Tilly, right? So not R will be, we will not visit Aunt Tilly, comma. Then the or statement. Does that make sense? Right, so that's why that comma makes such a big deal. Are we okay? Boy, you guys are going to have like a bunch of minute 30 videos for these 8 sections. Any other questions, guys? You're good? Are we sure? Okay. How about if I say it this